Hello everyone, I am your chemistry teacher, Professor Sachin Mungade. Welcome all of you in Sanjivani Lecture Management System. In today's class, we are going to discuss about the Faraday's law of electrolysis, and for that we should know about the mechanism of electrolysis and the concept of the electrolysis. Okay, so in a Faraday's law of electrolysis, the Michael Faraday in 1834. Michael Faraday is a scientist who conducted a number of experiments in 1834 in which he passed the known amount of current into the different electrolyte. As we know that we studied the electrolysis. What happened when the current is passed into the electrolyte means the solution, aqueous solution or the substance in a molten state or in a fused state. When the electrical current is passed into the electrolyte, at that time the chemical decomposition of the electrolyte takes place, and when the chemical decomposition of the electrolyte takes place, at that time cathodic reaction and the anodic reaction occurs. At the cathode, the gain of electron, that is the reduction reaction, takes place, on which the weight of the substance is deposited. Whatever the substance which is deposited on the cathode, they can be weighed later on. Similarly, the anode get dissolved into the solution, means they are losing their weight. So in 1834, the Michael Faraday conducted the number of experiments. In that experiment, he passed the known amount of current into the different electrolyte, and whatever the substance which are deposited on cathode, that substance are weighed by the Michael Faraday. So whatever the summary or the result which is obtained by the Michael Faraday, they are summarized in the form of two statements. Means whatever the conclusion he got on the basis of that two experiments, that conclusion they are summarized in the form of two statements. That statement are said to be a Faraday's law of electrolysis, that is the Faraday's first law and the Faraday's second law. Okay. So to understand the Faraday's law of electrolysis, it is necessary to understand some of the important terms which are used in the Faraday's law of electrolysis. The first one is the Coulomb, the second one is the Ampere, and the last one is the Faraday. So what is the Coulomb? It is nothing but the quantity of electricity that passes through the circuit when a strength of 1 ampere current is passed through a circuit for a 1 second. At that time, that quantity of electricity are said to be a Coulomb. So 1 Coulomb is nothing but it is the amount of electricity, or it is the quantity of electricity when a strength of 1 ampere current, pass through the circuit for 1 second. So ampere is nothing but the unit of the current. When a strength of 1 ampere current passes through the circuit for 1 second, then that quantity of electricity are said to be a Coulomb, that is the 1 second. Okay. Next one, ampere. It is the unit of current. That is, the current is passed through the circuit which deposited. When current is passed through the circuit which deposit this 0.001118 gram of silver on cathode, or to liberate 0.000104 gram of hydrogen, that amount of current are said to be a ampere. So what is the ampere? It is a unit of current which is passes through circuit which deposit this gram of silver if your electrolyte is made from the silver. If the electrolyte contains the silver, or it is the silver electrolyte, when the amount of current is passed through silver electrolyte, at that time this amount of gram of silver is deposited on your cathode, or if it contains the H plus, at that time this amount of gram of hydrogen gas is liberated on the cathode, then that amount of current are said to be a ampere. Okay. Faraday, it is the quantity of electricity. It is the somewhat biggest unit of the electricity. So it is the quantity of electricity that passes through the circuit to deposit or liberate 1 gram equivalent of the substance from that electrolyte. 1 gram equivalent of substance. 1 gram equivalent weight of substance from electrolyte. Okay. 1 ग्रॅम इक्विव्हॅलंट म्हणजे काय की त्याचं जेवढं इक्विव्हॅलंट वेट आहे तर तेवढं डिपॉझिट होण्यासाठी लागलेली इलेक्ट्रिसिटी म्हणजे तुमचं फॅरेडे. म्हणजे फॉर एक्झाम्पल आपण असं कन्सिडर करू की कॉपर मेटल आहे आणि कॉपर मेटल हा आपण कॉपर सल्फेट सोल्युशनमध्ये घेतला. ओके, मग कॉपर सल्फेट सोल्युशनमधून कोण डिपॉझिट होणार आहे तर कॉपर डिपॉझिट होणार आहे. मग कॉपरचं इक्विव्हॅलंट वेट जेवढं असेल, कॉपरचं इक्विव्हॅलंट से फॉर एक्झाम्पल 32.42 gram. This is the equivalent weight of your near about 32. This is the equivalent weight of your copper. Okay, so this amount of this gram of copper when they are deposited on the cathode, at that time that required quantity of electricity which is required for the deposition of 32.42 gram of copper are said to be a Faraday. So 1 Faraday is equal to 96,500. So these are the three important terms which are used in a Faraday's law. The first one is the Coulomb. It is the quantity of electricity or amount of electricity that passes through a circuit when a strength of 1 ampere current passes through the circuit for 1 second. That is a 1 Coulomb. Ampere, it is a unit of current passed through the circuit to deposit this gram of silver on the cathode or to liberate this gram of hydrogen, means 0.001118 gram of silver and to liberate 0.4 times 0104 gram of hydrogen are said to be a ampere. Faraday is the biggest unit of the electricity. It is the quantity of electricity that passes through a circuit to deposit 1 gram equivalent of the substance from that electrolyte. Equivalent substance from that electrolyte. The electrolyte copper sulfate जर असेल तर त्याच्यामध्ये सबस्टन्स कोण डिपॉझिट होणार आहे कॉपरचा. मग कॉपरची इक्विव्हॅलंट वेट किती आहे से फॉर एक्झाम्पल नियर अबाउट 32. मग 32 ग्रॅम कॉपर डिपॉझिट होण्यासाठी जेवढी इलेक्ट्रिसिटी लागेल तर त्या इलेक्ट्रिसिटीला आपण काय म्हणणार आहे फॅरेडे असं म्हणणार आहे. ओके, सो लेट अस सी द फॅरेडेज फर्स्ट लॉ. So this is the actual setup. So Michael Faraday in 1834 conducted a number of experiments. So we have electrolytic cell, electrode, electrolyte, and these electrodes are connected to the battery. What happens when electrical current is allowed to pass through the circuit into the electrolyte? At that time, chemical decomposition take place. So for example, consider this is your copper sulfate. Okay, and this is your cathode. This is your anode. So at cathode, what happens? This reaction takes place. Copper plus plus accept 2 electrons. There is a formation of copper metal. Okay, so here the copper is deposited on the cathode. So according to the Michael Faraday, the first law says that the amount of substance which are deposited on the cathode, or say for example if it is a solid, then that solid is deposited on the cathode. If it is a gas, if the gas is one of the product in electrolysis process, at that time we can use the term that is the liberation. The amount of substance deposited or liberated at cathode during electrolysis process is directly proportional to the quantity of electricity flowing through the circuit. Is directly proportional to the quantity of electricity flowing through the circuit. So for example, W is the weight of substance which are deposited at the cathode during the electrolysis process, and Q is nothing but the amount of electricity that are passes through the circuit. It is the amount of electricity that are passes through the circuit. So according to the Faraday's first law, the amount of substance which are deposited at cathode is directly proportional to the quantity of electricity that are passes through the circuit. So according to the statement, W is directly proportional to the Q. This is our first equation. But we know that the quantity of electricity that is in a Coulomb is nothing but, we already studied that term Coulomb. It is the quantity of electricity that is passes through the circuit when 1 ampere strength current is passes through a circuit for 1 second. So Q is nothing but the current in ampere which passes through a circuit for specific time. Okay, so we know that Coulomb is nothing but current in ampere multiplied by time in a second. So that is equation 2. So put the value of Q in a equation. First you will get W is directly proportional to the CT. Okay, that is C is nothing but the current in ampere, T is nothing but the time in a second, W is nothing but the weight of substance deposited at the cathode. Okay, so directly proportional आहे म्हणजे आपल्याला इथे काय करावं लागेल, कॉन्स्टंट घ्यावं लागेल, that is nothing but W is equal to ZCT. This Z is nothing but the constant and Z is called as electrochemical equivalent. Electrochemical equivalent. Okay. So according to the statement or the equation, if current is 1 ampere and time is 1 second, then you can put this value into the equation. You will get W is equal to Z multiplied by 1 multiplied by 1. So W is equal to Z. When current is 1 ampere and time is 1 second, at that time the weight of substance is equal to electrochemical equivalent. So electrochemical equivalent can be defined by using this equation. So by rearranging this equation, Z is equal to W upon Ct. So what is electrochemical equivalent? That is the weight of substance which are deposited at the cathode when a current of 1 ampere is passes through the circuit for 1 second. So this is nothing but the weight of substance deposited on the cathode when 1 ampere current, a strength of 1 ampere current passes through the circuit for 1 second are said to be a electrochemical equivalent. So this is all about the Faraday's first law. Faraday's first law states that whatever the substance which are deposited on cathode is directly proportional to the quantity of electricity flowing through that circuit. Means W is directly proportional to the Q, and you will get the equation W is equal to ZCT. On the basis of W is equal to ZCT, we can define the electrochemical equivalent. Okay. In Faraday's second law, what happened? आता दुसऱ्या एक्सपेरिमेंटमध्ये त्यांनी काय केलं माहिती आहे का, दोन वेगळे इलेक्ट्रोलाइट घेतले आणि त्याच्यामधून सेम अमाऊंट ऑफ इलेक्ट्रिसिटी पास केली. मग त्यावेळेस त्याला जे काही ऑब्झर्व झालं तर ते असं ऑब्झर्व झालं की दोन्ही त्या इलेक्ट्रोलाइटमधून त्या कॅथोडवर जो काही सबस्टन्स डिपॉझिट झालेला आहे तर तो सारखा नव्हता. म्हणजे इन दॅट केस द वेट ऑफ सबस्टन्स विच आर डिपॉझिटेड ऑन कॅथोड through that electrolyte is not the same. Means it means we can say that the weight of substance which are deposited at the cathode is not directly proportional to the quantity of electricity flowing through the circuit, as the quantity of electricity flowing through the circuit into the different electrolyte is same. So in the equation, when the same amount of current or the electricity which are passes through the battery into the two different electrolyte. So here the first electrolytic cell consists of, say for example, copper sulfate. This is the first electrolyte, and in the second electrolytic cell we have taken the silver nitrate as the second electrolyte. So these are the two different electrolytes, where these two different electrolytes they are taken in a two different electrolytic cell, where the battery is one, and through the battery the same amount of electricity is passed into the different electrolyte. Okay, so this is your electrode which is connected to the negative, so it becomes cathode, and in the second electrolytic cell we have taken the electrode which are connected to the positive, so it becomes anode. One is anode, in the sense the second electrode becomes cathode. If this is the cathode, the second electrode becomes anode. When the same amount of current or the electricity is passed to the circuit into the different electrolyte. At that time, from that electrolyte, the metallic cations, they are deposited on the cation in the form of neutral metal atom. So here, this is a cathode. From the copper sulfate, the copper metal is deposited on the cathode, and this one is your cathode, and the solution is the silver nitrate. From the silver nitrate solution, the silver metal is deposited on the cathode. Okay, so whatever the weight of substance which are deposited on the cathode, from that corresponding electrolyte is directly proportional to their chemical equivalents, and not on the amount of electricity. तर ह्या केसमध्ये कॉपर सल्फेट मधून जो काही कॉपर डिपॉझिट झालेला आहे कॅथोडवर, आणि सिल्वर नायट्रेट मधून जो काही सिल्वर डिपॉझिट झालेला आहे दुसऱ्या कॅथोडवर, दुसऱ्या इलेक्ट्रोलायटिक सेल मधल्या इलेक्ट्रोलाइट मधून जो काही तुमचा सिल्वर डिपॉझिट झालेला आहे, तर ते सारखे नाहीये, म्हणजे ते क्वांटिटी ऑफ इलेक्ट्रिसिटीवर अवलंबून नाहीये. ते जर सारखे असते तर आपण काय म्हणणार आहे की ते क्वांटिटी ऑफ इलेक्ट्रिसिटीवर अवलंबून असते, कारण सेम क्वांटिटी ऑफ इलेक्ट्रिसिटी आपल्याला केलेली आहे, दोन्ही इलेक्ट्रोलाइटमध्ये पास केलेली आहे. परंतु सेम क्वांटिटी ऑफ इलेक्ट्रिसिटी पास केल्यानंतर सुद्धा जो काही सबस्टन्स त्याच्यावर डिपॉझिट होतोय तर तो सेम नाहीये, म्हणजेच काय, दे आर नॉट डायरेक्टली प्रोपोर्शनल ऑर डिपेंड्स ऑन दी क्वांटिटी ऑफ इलेक्ट्रिसिटी दॅट आर पासिंग थ्रू द सर्किट. मग ते कशावर अवलंबून आहे किंवा डायरेक्टली प्रोपोर्शनल कोणाच्या रिलेशनमध्ये येतात, ते त्याच्या केमिकल इक्विव्हॅलंट्स, दॅट इज कॉल्ड एज द सी केमिकल इक्विव्हॅलंट्स. सो अकॉर्डिंग टू द इक्वेशन, दी W is the weight of copper which are deposited from the first electrolyte. So this is the first electrolyte is a copper sulfate solution. From the copper sulfate solution, the copper is deposited on the cathode, that is your W copper is directly proportional to the equivalent weight of copper. E means equivalent or the chemical equivalent according to the first equation. And in the second compartment, from the second electrolytic cell, the W silver, in the sense the silver metal is deposited on the cathode, that has a specific weight. So W silver is directly proportional to the E copper. That is the second relation. So dividing equation 1 by 2, you will get W copper upon W silver is equal to E copper upon E silver. This is the Faraday's second law of electrolysis. So these are the two laws of the Faraday's first law and Faraday's second law of electrolysis. So with this we conclude our today's lecture. In the next lecture we will learn the next concept. Till then, goodbye. Thank you.